Alright guys, here we go. This is the second video. We're talking about just the graphs. I want to give you a quick picture as motivation for what these different interest rates look like graphically. So when I go to graph, the one I usually use is Desmos graphing calculator. We did the Desmos scientific calculator for our other calculations, and we're going to use that later on. But for now to see the picture, I'm going to use the graphing calculator. So just Google Desmos. Oh, I spelled that wrong, but it doesn't matter. Google recognized what it was supposed to be. And just click on Graphing Calculator Desmos. It's going to take you to this site. I think it's nice and pretty set up. All right, so I'm going to type in three different formulas. The first one is a simple interest formula that I just gave you guys. It's A equals to P plus RT. Yeah, P times parentheses 1 plus RT. Okay, the second formula I'm going to type is the compound interest formula. That's A is equal to P times 1 plus R over N to the NT. Yeah. Okay, the third formula I'm going to type is the continuous compound interest formula. A is equal to P e to the RT. And if I type in E here, actually the graphing calculator, this particular graphing calculator, recognizes that E is that number, kind of like pi, right? So this is roughly 2.718, blah, blah, blah. All right, the last thing I'm going to do is just going to add sliders. So sliders are just going to let me play with these numbers and move them around. The bottom axis, the x-axis, I'm actually going to change to the t-axis. So what that's going to represent is time. As time progresses, how much money are you going to end up paying if you're borrowing, or if you're lending, how much you're going to end up getting. Okay, so everything else I'm going to add a slider. The bottom axis is going to be the time. Okay, so right away here's a quick picture. Now this is for n is 1 year right now. I'm going to change the bounds of this. Going to start with 1 year, and let's go to, let's say, like, I don't know, 60 years from now. Okay, 1 to 60. I'm sorry, I have the wrong. That's not correct. N is the number of compounds per year. So let's go 1 to, I don't know. Let's just go to 1 to 100 and steps of 1. And oh, this guy got rearranged somehow. This guy was supposed to be up here. This guy's supposed to be up there. All right, so the other thing I want to do is just change, look at the rates. Remember, rates is the rate is a decimal, right? So it should start from something above 0. And you know, like a typical rate, it's not going to go much past 10%. 10% would be 0.1, right? And let's go by steps of 0.01. So in other words, steps of 1%. Okay, just as an example. All right, your principal. This is how much money you're starting with. Let's start with, let's say $1, and let's go up to just $1,000. We'll go by steps of $10. Okay, so we'll kind of play around with these and see what the graph will look like. To start with, let's just start with a single dollar. Let's say our interest rate is, I don't know, 5%. And let's say it's compounded, I don't know, let's say 12 times a year, so monthly, in other words. Okay, right now my graph, it's kind of hard to see the details. So what I'm going to do is I'm going to just expand my window so that we can kind of see better. Oh, actually, no, I take that back. You can pretty much see it already. Yeah? One interesting. Okay, so one thing that I noticed is right away, this red line represents a simple interest, right? Linear. It's a linear equation, so it just grows like a line. That's not bad. But if you look at the compound interest formulas, actually the blue and green one, they're almost on top of each other, right? You can't even see the blue line because they're so close. Here, I'll zoom in so you can kind of see that they actually are slightly different. Here we go, way zoomed way in. They're actually slightly different. But surprisingly, by compounding interest over and over again, you actually don't get that much benefit. Let's move it down to once per year. We can see the difference a little bit more, yeah? If I only compound my interest once per year, then we see the gap is kind of widening. And as we go on, as time progresses, that gap does widen a little bit more. All right, that's for $1. Let's increase our values to, let's say we start with $500 or 501. You notice now, okay, my graphs are off the charts, right? So I need to adjust my settings so that I can see things. Let's go from let's just go from 0 to, I don't know, let's go to like 10,000 or 100,000, see. No, looks like 10,000 is about the right choice. Okay, so let's do a little interpretation. Let's see where we're at in 10 years with simple interest. That's the red line. Right, at 10 years, I'm about $750. Let's follow this blue line with compounding once per year. At 10 years, I'm at $816. Okay, and with the green, continuous compounding at 10 years, I'm at, what is this? 826, so a little bit more. All right, but as you see, like as time progresses, that gap widens, right? So let's go up all the way to like say 40 years from now. If I have simple interest, I end up with 1,500. Not bad. I tripled what I started with. But 40 years using compounding once a year, I end up with about 3,500. So what is that? That's like 7 times what you started with, right? Now 7 times that multiplication factor is going to be true regardless of what I started with. So if I started with $1,000, that's going to end up with 7,000. And for continuous, a little more even, yeah. So yeah, even a little more than the compounding once a year. Now, if I compound 12 times a year, though, notice that actually it's pretty close to continuous already. Yeah? These guys are almost indistinguishable. So 12 times a year is already pretty good. You don't have to really go all the way up to compounding continuously. Okay, what else I want to say? I do want to just make one more observation. Just kind of like let this picture sink in. Let this curve sink into you. Like see how radically it's growing. In fact, this is only for 5%. So if I change to something like 7%, like I don't know, my some of my stocks that I invest in, they're gaining roughly 7% on average a year. So something like that, if I was to input my original, $500, end of 20 years, I'm already at 2,000. I've already quadrupled. End of 30 years, you're at 4,000 from 500. So that's times what, 8, factor of 8 after 30 years. So yeah, that's 7%, and this could fluctuate more and more. So if you go all the way up to 10%, or if you go to like what interest rate a credit cards would charge you, like let's say 18%. Then look at that thing, dang, that's brutal. So if you're like 10 years from now, you're letting that interest accrue for your credit card from, what is this? It was 500 start rate, right? 500, and then in 10 years, you're at 5,000. It's 5,400. That's like almost 11 times what you started. So yeah, that's just a picture I want to give you guys for the interest, what's really happening behind these formulas. Okay, I'll stop this and then we'll go on to the next formulas in the next video.